Good evening, all of you. Welcome to the 22nd webinar in the Thursday webinar series organized by IEEE Malabar Subsection. As you are aware, we have started this webinar series from June 1st onwards. So without any break, we could conduct 22 webinars in this series. So today we have a very hot, a very important topic, that is machine learning. And today's speaker is Dr. Shihabudheen, a gold medalist from NIT Calicut. And he got his PhD from IIT Roorkee. So he has agreed to give a talk on machine learning. So on behalf of Malabar Subsection, I welcome Shihab, as well as I express my thanks to Shihabudheen for agreeing to give a webinar in this series. So I request Dr. Taslima to introduce the speaker to the audience. Over to Taslima.
Thank you, sir. I also welcome you all the audience for the 22nd webinar on that is organized by the IEEE Malabar Subsection in collaboration with the IEEE Malabar Hub. And today's topic is about tools and techniques for machine learning. And it's my pleasure to introduce the speaker, who is Dr. Shihabudheen KB, who is the Assistant Professor in the Department of Electrical Engineering, NIT Calicut. Shihabudheen received his MTech in Instrumentation and Control degree from National Institute of Technology, Calicut, with Gold Medal Award. He completed PhD in Machine Learning and Intelligent Control from IIT Roorkee. Currently, he is working Assistant Professor in the Department of Electrical Engineering, NIT Calicut. His research interest includes nonlinear and intelligent control systems, soft computing and hybrid system, renewable energy harvesting and control, machine learning, deep learning, and robotics. Sir, we are very happy to have you here today for this 22nd webinar organized by IEEE Malabar Subsection in collaboration with IEEE Malabar Hub. And I welcome you, sir, for today's webinar.
Thank you. Now you can possible to see my screen, right?
Yes, sir.
Yeah, I'm going to off my video because they're telling that there is a bandwidth issue. So I'll off my video.
Okay, sir.
So good afternoon, all of you. Here I'm delivering a small idea about machine learning and what are the techniques which is available. Maybe a brief idea about the technique regarding the machine learning. So basically, I have prepared this presentation keeping UG and PG student in my mind. I will try to give an overview of machine learning to the students, and also maybe it may be motivated them to pursue the research in this field. Basically, once again, telling that I'm planning to give only the fundamental concept of machine learning. So when it's coming to the idea, as we know, this is a T-Rex game, and normally we'll play this game when in the absence of internet, right? It's an inbuilt browser game in the Google Chrome. We use by hitting the space bar when in the offline on the Google Chrome, right? So basically, there is a dinosaur. A dinosaur is it's try to avoid the obstacle. When an obstacle is came, it will try to jump it, and this is a process. Now, normally what we'll do, we have to press the space bar to jump a dinosaur. Now you can think about an autonomous system, an automatic system, which can play this game automatically. So you can think in a learning strategy or learning system. There are two type of learning system you can think about in this dinosaur game, or also called a T-Rex game. You can simply measure the distance between the obstacle and this dinosaur, and accordingly you can think about a adaptive strategy where it can jump when an obstacle is reaches nearer to or maybe certain distances. This is called a conventional adaptive strategy. In second strategy, which is
Hello, sir. Shihab sir, your voice is not audible here. Shihab sir. Hello. Sir, your voice is not audible.
now what?
Now it
It's
is
audible
okay.
now?
Now it is okay, sir. Fine.
Okay. So what you can think about the two strategy to do an automatic gaming in this field. So what first I told you, we have to design an adaptive strategy where we can measure a distance between the corresponding dinosaur and the obstacle, and accordingly when the obstacle reaches nearer to a certain when obstacle reaches nearer to the dinosaur, then we can give a jumping picture. This is adaptive strategy. And the second strategy is called a learning strategy. That is basically we can learn the behavior of a dinosaur through certain experiences, through repeated iteration. So we have to train a learning system, or we have to train a dinosaur such that it can jump the dinosaur when an obstacle is coming. So we have to make a jump. For example, if we are applying, assume that we are applying a reward-based uh, uh, learning strategy. So when the dinosaur jumps the obstacle successfully, then we can give a positive reward to the dinosaur, so that and when the dinosaur touches the obstacle, then I can say that it's a negative. We can give a negative rewarding on the learning strategy. So we can create a learning strategy accordingly, such that it maximizes the reward received by the dinosaur, or I can say the agent. And in this way, we can do certain sort of simulation, and finally, we can create an action. That action can perform a jumping strategy automatically. So we'll come to the detailed analysis, detailed study in the coming slides. Okay, so there are a lot of application we can apply this machine learning strategy. For example, in this case, it is image classification. A image is given to you, and it is possible to uh, find the object presented in the images, right? There are a lot of objects are there in these images. We can think about a learning mechanism or machine learning mechanism which can categorize the images, or which can categorize the object which is present in the images. And another application is basically object detection, right? So instead of classifying the object, here where is exact here, this will determine the exact location of the object, or exact location of different object in a given image, right? And we can possible to draw a bounding box in a specific object according to a learning strategy. And another application we can think about in automotive industry, and a automatic car. I think the recently Tesla has invented a automatic car, right? So which can use for automatic running purpose. And I think Toyota, you can see the picture. The Toyota have a night view in these cases, and you can see whether any object or obstacle is there in the present. Accordingly, it will take an action to give a positive result. And here is another example which can detect the face from a given set of bigger images, maybe 1 billion of images given to you. So if a test image is given to you, then it will a machine learning technique can provide a specific images which is exactly matches the input images. So such image identification can also possible using the machine learning. I can say that maybe advanced version of machine learning, which is called a deep learning. That technique can be used to identify if number of images is more than or maybe 1 billion images are available. Then we can think about a deep learning strategy to identify the different phases, and also face verification, whether a given face is similar to two different type of face is similar or not, or also maybe predict the identity of a given images. All the cases we can think about a machine learning strategy which can learn certain experience from the given data. Now we are coming to what is machine learning. Basically, machine learning is a concept of turning the data into a certain information. So I'll give you an example, basically detecting a spam mail in a given email system. And what normally will do, even we can think about a spam detection technique, whether there we have to collect certain uh, features from the given email.
Current
For
subset.
example, we can check occurrence of a certain words which is used together, or a combination with the length of the email, or the email country which is coming from a particular address, or maybe a email which is coming from specific country. Like that we can make a specific I can say that features. After that, you can, based on these features, we can identify a classification mechanism, whether is this given the coming mail is spam or not. So that means we have converting the data into certain information. What is the data? Data indicate the given mail. From the given mail we have constructing a required features. After the features, the data will be transformed, the features will be transformed into information. What is information in this case? Whether given mail is spam or not. Okay, so once again, I'm giving you the what is machine learning. As per the Wikipedia, machine learning is an ideology, or I can say that a computer system that can adapt or learn from the given experiences. So we can consider a generic system, a general system, which have a certain number of input, and it will produces a certain output y, right? So, and we can think about there will be a hidden variable or hidden system or hidden parameters which will be available in a system, right? So there is an input system, input variable which is indicated by x, and output variable which is indicated by y, and there is a hidden system or hidden relation which is called h. Maybe I can tell as a hidden variable. So in this cases, in this generic system, when we are coming to a machine learning system, what is actually the input in a machine learning system? Input is transferred to the output through a certain hidden information. That information is called it will provide the knowledge. The information H1, H2 is called, it will provide the knowledge. It will capture certain knowledge from the input data, and it will transfer to the output according to the knowledge representation. So, as we know, the machine learning technique is a combination of different areas, just like statistics, control theory, economics, evolution, computer science. Is a combination of different areas which is mixed together. And there are a lot of terminology associated with machine learning. You can see that the classification, regression, data set, pattern, artificial intelligence, feature, data mining. There are a lot of terminologies are available, which is associated with the machine learning technique. Now, when we are coming to the system, I told you and hidden. hidden parameters, if the relation between input and output and hidden are completely known to you, then in such cases, it is not required to think about machine learning algorithm. Unlike we can think if there is a conventional mathematical algorithm which is available in between the input and output with the hidden parameters, then you can think about a conventional mathematics algorithm which will provide an output for a given input. Right. Or another strategy you can if the even though this the relation is known to us, that relation may be complex or maybe an iterative environment. In such cases, also we can think about machine learning algorithm, which is a I can say it is a simplest algorithm which can correlate the input variable to output variable through a certain hidden parameters. So why we are using this? Why we are using machine learning in current scenario? Basically, machine learning system has a capability. There are a lot of capability. So capability to automatically adapt and customize themselves to the individual users. For example, I told you in the last example, what is that? It is to detect a particular mail is spam or not. So even though human can do it in certain cases, but we can think of an automatic strategy which can adapt and customize for a specific purpose, our individual users. That is one speciality when it's come to the machine learning. And another idea which is called uh, data mining. When it's come to the data mining, we can discover a new type of knowledge. I can say that a new correlation between two different large database, two different data sets. So that is one of the important application of a machine learning technique, data mining. Basically, Amazon and other market and people will do such correlation to increase their productivity, right? And maybe I can say, there is a story behind diapers and beer. You know the story. Basically, one of the world famous retail shop Walmart was found that they found some correlation between the selling diapers with the selling beer in a showroom, the Walmart showroom. And they have certain time, especially on the Friday evening, the production of, I mean, selling of beer, it is highly correlated with diapers, particularly both are together. And this idea they have found through discovered through data mining strategy, because this normally what Walmart discovered such a auspicious relations through a data mining strategy, and it may not be understand by a human because of didn't have a background knowledge regarding this correlation, right? The reason is that because working man who had been asked to pick up a diapers from a shop may buy a pack of beer from their usages, especially in the weekend day. That they have found a correlation between these two, and accordingly they can increase the uh, product selling capability, or maybe they can put diaper and beer together for better showing. And the third important is that the machine learning technique can ability to mimic human, and it can replace certain tasks, human tasks, with which require some intelligence. For example, recognizing the handwritten characters, we can easily identify it, right? So through our human intelligence. But say the same topology we can apply, we can think about a machine learning technique which will do the same process. And another thing which another application is that basically human, if a data containing data is large, was very difficult to expensive construct manually, because it requires maybe a skilled work is required to do specific task. In such cases, a human cannot possible to do such a bigger skilled task, right? In that cases, we can think about a machine learning strategy which can do this task very easily. For example, person identification from a given lack of images is very difficult task for a human, right? But even though this much of advantages, in the current scenario, these machine learning techniques are boosted in the why? Because of that, there are flood of data are available in the current scenario through the internet. We can download lot of thousands of data set from the internet. That is one of the advantages. Second is there are current time there are increasing computational power. There are lot of higher computing facility like GPU facilities are available in current scenario, and other thing is lot of advanced algorithms are available, which is invented by researchers, which is available, and also their code they are putting in open source as open source. So every person, those who are interested can download the code and they can use there for specific application purpose. And also it will get lot of support from industry to do a specific project. And you can see the computer world, it is a famous digital magazine. They have categorized 12 important IT skill, so that an employee can't say no to the specific. They have categorized that machine learning is a first skill which can be have a greater emerging capability. Now we'll coming to some terminology associated with the machine learning, which is called, there are two terminology which is called classification and regression. What do you mean by the classification? Classification basically there is a predicting the labeled data from a given data set. So, for example, if we want to check whether there is a chance of rain tomorrow or not, right? So what we can do, we will check. It will predict you there is a whether rain is there or not, yes or no capability. So that is called the prediction specific to a class label is called classification. Another one, regression. Regression is basically a model of continuous function. It's getting an exact value, right? For example, we can predict the estimate the tomorrow temperature or stock market index, all the thing we can predict actual value. So prediction of actual value, it is related to the regression. And when it's coming to if assume that there are bunch of data is given to you, we have to, so there are some terminology associated with the data. So you can see that this data, how many inputs are there? Basically, there are 4 inputs, which is called the number of new recipient, email length, country, and the customer type. This is called input attributes, or I can say that the input, there are 4 input is available. And another thing, there is output attributes, which is called, you can see the email type, which will provide you whether a harm email or spam email. This this is called attributes. And the number of data, it is generally termed as instances. And what about the data set? It may have numerical or categorical. So these are some terminology associated with the data set. Now, what we have discussed, we have a data set, we have a database, also called a training set, and we have a machine learning classifier, machine learning model. Then to transfer the data into a machine learning classifier, we require a intermediate mechanism, which is called the learning algorithm, or simply induction algorithm, which will learn to do a specific, learn the classifier to do a specific task. So I know, I think you know about a lot of learning algorithm, just like genetic algorithm, back propagation algorithm, gradient descent algorithm, K-means algorithm. Maybe different type of algorithms are there to find out mean according to the specific application, we can choose a algorithm to do a specific task. Now, let coming to the different topology of a machine learning. These are the three important topology of machine learning. What are supervised learning, unsupervised learning, and reinforcement learning. The supervised learning, as you know, it's a learning of specific algorithm, or I can say the specific architecture through assume that the output values are given to you, or maybe learning through just using a teacher, right? Like classification, when we are doing a classification to during the training process, we should have to know about the output labels, or if we are doing the regression, we have to know the output exact value to do the training process, which is called a supervised learning. When it is coming to the unsupervised learning, basically it will find out only the input data are there, there is no output data. Based on the input data, it will find out some relationship between the input data, and based on this relationship, we can categorize this data to a specific task. And reinforcement learning is basically it is a reward based process, and which will provide you a positive reward or negative reward to do a specific task according to the a specific criteria. Now we come to different type techniques which is available in the machine learning. These are the some commonly used technique which is generally available in the. There are a lot of other techniques are there, deep learning and what other than neural network. Other than neural network, there are a lot of advanced versions of neural network, and there are different techniques are available. Out of this one, I'm planning to give a small overview of these 5 techniques related to the machine learning. Now, let me come to the idea of decision tree. And you know, the decision tree is one of the tree-like structure algorithm, or which commonly used for the classification, especially for the classification purpose. And you can see very importantly, if we have a data set may have a certain missing value, or maybe some irrelevant features which can perform a better cases when we are applying a decision tree. So I'll give an example. This is a data set which will provide you whether we can play the tennis or not according to the 4 features. So how many input features are there in this case? There are 4 input features and 1 output feature. Total number of instances is 14. There are 14 data are given. What are the input data? Output, temperature, humidity, and wind. These are the input data, and it will provide to you an output as whether give you whether we can play the tennis or not based on this information. So now we are finding a correlation or a relation. We are making a relation between the input and output through a tree-like structure. You can think about we are taken as a first attribute as is called the test attribute. We taken as test attribute. Out of that, there are 3 different possible values are there. What are the values for the output? Sunny, overcast, and rain. These are the 3 important. And it can easily understand that through checking the data set, it can understand that when output become overcast, then obviously we can play the tennis. Then when it's coming to the sunny, then there are 2 different, again they can take another attribute, humidity, and you can check whether there are 2 different possible conditions for humidity. Humidity may be high and humidity may be normal. According to this one, we can provide whether we can play the tennis or not. And here also there are 2 different interconnection. The rain can be interconnected to wind, and which there are 2 different possibilities are there, strong and weak, which will provide. And if it is strong and it based on the training data, it is obtained that if wind is strong, then it is not possible to play. If it is wind is weak, then we can play the tennis. So this is a concept behind decision boundary. We can make a correlation between this attributes values, and through certain T-like structure we can give an output. And you can see this example once again. There are we can take outlook as a first option, and if we are taking outlook and the corresponding output, we can say that there are 9 S are there and 5 nodes are there, and we can take 3 different category of a outlook. And we can, when we take the overcast, and you can all the cases the output we are obtaining as yes. So we can directly interconnect the output as yes. When it's coming to the another case sunny, then these are the data set accordingly. And if you are checking about the sunny data, and you can see that there are 2 yes and 3 no's are available. And if you are checking the outlook as rain, and you can see that 3 yes and 2 no's are available, then if it is happen, then you can take the next attributes. The next attribute is humidity. Then what are the different categories? High and normal are the different category. According to that, you can divide the data, and you can take a decision. And rain also have a different category, and you can categorize the data accordingly. And finally, you can make a tree-like structure. Let's assume that there is new data is given. Now the trainings are over. Once the tree-like structure is found, then we can say that the training is over. When new data is coming, let give a new data, 15th day data. Outlook is rain, hum, humidity is high, and wind is weak. So output is rain. Then it automatically reaches here. But rain has no relation with the humidity, so we are not checking the humidity relation. And you can see that now the rain is going to the wind actually. So we can check the output of wind, and wind is basically, it is weak. When it's weak, then we can say that as per the previous training, we can understand that this is output should be, we can play the tennis. Through this tree-like structure, we can easily construct a algorithm, or I can say the connectivity algorithm. Now we'll have a confusion. Which attribute take as a first one, right? Which attribute? There are, in the previous case examples, there are 4 attributes is there. We have taken outlook as a first attribute. There are the other 3 attributes also there, right? Which one take as first one? Then that idea, it is we are checked through the purity or impurity of the information. As you know, the impurity of a given function, it can be, or I can say the randomness of a given function can be found by using the concept of entropy, right? So this is an entropy equation. As you know, this is a P plus indicate the positive example, and P minus indicate the negative example. This is the equation for entropy. And like this is an example, you can see, we can find out there are 9 positive example and 5 negative example. We can calculate the entropy. Entropy is a measure of randomness basically. Then we have to check the information gain, how much information content is available in a particular attributes. So you can apply this equation to find out the information gain, and accordingly you have to calculate the information gain corresponding to the each attributes. Let me calculate the information gain corresponding to the wind. There are 2 output. What are the output? Weak. There are 2 options, weak and strong, right? When S is weak, there are 6 positive and 2 negative values, and S is strong means the 3 positive and 3 negative value. Then you have to calculate the information gain corresponding to the wind, and we will obtain a value. Like that, you can calculate the information gain associated with each and every attribute. These are the 4 attributes. Out of this one, you can understand that outlook have a more information. That means outlook is more related with the output sample, uh, which is identify that its information gain is higher compared to other. And outlook has a higher information gain. And then you can see the next case is humidity, and after that we have obtained as a wind, and finally it is temperature. So like in this, so what you have, the outlook we take as a first one, and after that we can draw a tree like structure, and there are three different possibility we can plot it. And after that, when it's coming to the second stage, when it's coming to the second stage, again you have to calculate the information gain associated with another attributes, and you can find out which attribute is more close, having more information gain. Accordingly you can select a specific attribute related to the specific relation. Okay, what we have calculated, humidity is more uh, getting as more information gain. So we have used as this humidity as the next attributes, which is connecting to the outlook to the through the sunny. Now this is a idea behind decision tree. The decision tree are using for lot of application for classifying medical images, lot of applications. When it's coming to issues, actually, it's certain cases, if more number of attributes are available, then making decision tree is a bigger task. It's require a lot of computational effort to do the training process. Let me come to the second method, which is called a neural network. What is a neural network? Basically, neural network is, I can say that is a crude approximation of a human brain, right? Even though human brain has a lot of operations, we are just taking the concept of parallel operation and the learning capability. So we are mimicking the parallel operation capability and learning capability of a human brain, and making a network is called artificial neural network. And uh, I can say this neural network is an oversimplified approximation of a human brain. I'll give you the concept of a neural network through an example. Let let consist. This is a data set which is given to you. I can say this is labeled data. There are two input data, and I can say that two input attributes and output is a classic. This is a classification data, and eight examples are given to you, right? And it's a two-class classification problem, and this data is basically is a diabetes problem. And there are two features, x1 and x2. X1 is, it is a weight of a person by 100. X2, I think it is a length of divided by 100. Anyway, these are the two uh, features has is been selected, and it will provide output. When it is output is 0, then I can say that the person is diseased, not deceased. When output is 1, then I can say that person is deceased, diabetes. In these cases, you can try to plot a graph between the two attributes x1 and x2, and you can see that this is an example. The red line indicate an example, which is an example related to the diseased data, and this white this indicate a example which is related to a non-diseased data, and you can clearly draw a decision surface or boundary which discriminate the positive samples and negative samples, and we can make an equation of a decision boundary in this form. And this in the, maybe assume that the equation is x1 plus x2 minus 1.5 is equal to 0. And you can think about a neural network architecture which we can perform this decision boundary concept, right? So you can there are our aim is to incorporate a decision boundary or decision surface which can classify or which can discriminate the positive samples and negative samples. So we have two input x1 and x2 which is connected. You can say that it is x1 plus x2, right, which is connected and it is added together, which is, and one more input is there is minus 1.5. So we can give the minus 1.5. After that you can, what is our cases, basically this the x1 plus x2 minus 1.5 is generally we have noted as the decision surface, which generally w transpose x plus b. So this is the equation of a decision boundary w transpose x plus b. If w transpose x plus b is greater than 0, then I can say that it coming under the positive samples. If w transpose x plus b, it is less than 0, then I can say that it is coming under the negative samples. Now you can think a small activation function or function which will provide an output if given input sample is greater than 0, then it will provide 1. And if input sample, maybe the sample mean the, what is that, it is some summing value, net value. If the net value is less than 0, then it is output should be coming as 0. So this is a simple structure of a neural network. If uh, the the surface between the positive sample and negative sample coming as linear, then we can simply create a neural network architecture like this. But actually, most of the data is not, we cannot possible to create a linear decision surface which can discriminate the positive samples and negative samples. For example, if you are considering the XOR gate, right, these are the diagram of a XOR gate. What is that? 0 0. If you are coming 0 0, output will be 0. If 1 0 and 0 1 cases, output are coming as 1. And if its input is 1 1, then the corresponding output is 0. Is there whether we can possible to draw a single decision boundary which can discriminate the positive sample and negative sample? No, it cannot possible. We have to think about a non-linear decision boundary, which can discriminate the positive samples and negative samples. In that cases, we can provide a more hidden layers which will incorporate this non-linearity. So if we provide a more hidden layers in this structure, which will implement a non-linear decision boundary, the basically hidden layer will provide you a non-linear decision surface which can transfer the input data into the output. So this is a connection of a overall network. Let come to how we train a neural network if we have hidden layers. Basically, so one of the popular algorithm which is called back propagation algorithm, and I think you know about the back propagation, right? So I give a simple concept regarding the back propagation. We have a input pattern and we have an output pattern. This is a network that we are going to be trained. Now what we can provide the input pattern, and here it will provide an output. This is called the forward pass. Let assume that the output we have calculated and the corresponding target value is known to you. Then we can find out the corresponding error terminology. Error term associated with the output we can calculate it. That error is propagated back to find out the weight. More equation wise, you can see here for a given training samples, x1 and x1, x2, xn are the input samples and t is a target value. So you can give this input to the network so that it will provide an output. Okay, then you have to calculate the error terminology. I can say that delta k associated with the output network. This is equation to find out the error term associated with the output network. Then as per the some equation, you have to calculate the error term associated with the hidden network. Then you can update the neural network weight through an iteration, and finally all the network will converge to a specific application. I'll show you a small demonstration which is available in the TensorFlow online. Whether yeah, this is a platform where it can understand easily what is the working of a neural network when we add a hidden layer. You can say I'm taking a simple data. This is a classification data, and you can see the is positive samples and negative samples. Our aim is to find out a decision surface which it can discriminate the positive samples and negative samples. There are two inputs, x1 and x2 are the input, which is directly connected to the output. This is the output speed. Now I am going to train the network. The network does not containing any hidden parameters. So I just training it. You can say that, and the without hidden layer itself, this this network can possible to discriminate the positive samples and negative samples. Why? Because of this is a linearly separable data. We can clearly draw a straight line or linear line between the positive and negative samples. When it's come to a somewhat higher complex, maybe complex data set, you can see this obviously is a non-linear separable data, and when we are applying a simple input-output pattern, it cannot possible to draw a decision surface, right? So what you can think about, you can add a hidden layer, and maybe 1, 2, 3 hidden layers are added, maybe more hidden neurons I added, and you can start the training. After the training, what you can understand that almost we can using the training, and we can possible to discriminate the positive value and negative value easily. So adding more hidden neuron, we can say that it is better, is good for a complex network. But for a simple network, if you are adding more hidden neuron, there is a chance of overfitting problem. But this ideology, if a data set is complex, then you can add more hidden neuron. This ideology is a fundamental concept behind the deep learning. Now let me come to the support vector machine. Unlike neural network basically what is, we are calculating a decision surface between the positive value and negative value, and we can draw a decision boundary, right, in this form. But generally, there are infinite number of decision boundary we can plot it, right? Which one is optimal? So in case of a support vector machine, we are calculating a optimal decision boundary so that it can maximize the margin between the positive sample and negative samples. You can say in these cases, there are two type of boundary we can plot it, right? Two type of margin you can plot it. And you can see that this margin become as a maximum width. So I can say this is center line is a decision boundary. Center line is a decision boundary. So this line will provide you a better accuracy compared to the second line. So what is our support? What support vector machine is doing? Support vector machine try to get a maximum margin between the positive samples and negative samples, and this is this point which touching the margin line, which is called the support vectors. And then it's simply is very easier concept. We can do an optimization problem. We can think about an optimization through mathematics. We can understand the distance between the two surfaces, W transpose X plus B is equal to 1 is the first surface. Second surface is indicated by W transpose X plus B is equal to -1. And the central line is a decision boundary, which is W transpose X plus B equal to 0. And distance between we can easily calculate it as 2 by mod omega. And we can think about a optimization, I can say the quadratic optimization problem that can maximize the margin for a given training samples. So use this concept and Lagrangian approximation to find out the optimization. After that, you do the optimization accordingly, then you can calculate the optimal weight and bias. You can formulate the dual problem accordingly, then you can create actual weight and bias to get an optimal result. Now, when it's coming to the nonlinear case, actually, I told you most of the data is nonlinear. The decision surface between the positive sample and negative sample is a complex boundary, right? In these cases, normally you can think about a transformation. You can think about a transformation where into a higher dimensional plane, or maybe another plane, another dimension, where the data become linearly separable. This is a two-dimensional plane where we can say that this is non-linearly separable using certain transformation equation. This transformation concept is called the kernel concept. Kernel. Using certain transformation, you can convert into higher dimensional plane where the data become linearly separable. So now you can formulate the support vector machine, and basically these are the different kernel function which can be used for the higher dimension transformation. Linear kernel, then Gaussian, sigmoid, lot of kernels are used, and the selection of kernel is depend upon the complexity of the applications. And there is a two parameters is there to calculate it. The kernel parameter C, and there is a regularization parameter sigma. So that we have to calculate it using training. It's called a cross validation algorithm. I'm skipping that area. If somebody want to use this SVM, the SVM toolbox is available, which is more related with MATLAB, Python, or also the Python code, MATLAB code, or R code is also available. So if you want, you can download the libsvm toolbox for doing the this. Now I'm skipping certain area. Now it's coming to reinforcement learning. In reinforcement learning, basically it is a learning which is happening, which is doing through certain experiences. So I'll give an example through training of a pet. Let's assume that we are going to train a pet to catch a stick from a distance place. Okay, so what we have to do, let's assume the age, we require an agent that, or I can say that the pet is assumed as an agent, which will do an action. Okay, so that action, what we can say, when we require a training agent, the pet require a training agent, we normally will tell to do this process of fetch the corresponding stick, like that we'll inform, right? So we are the environment, and what the pet will take a corresponding stick and will do an action, right? That is called action. You can see the action which is interconnected with the environment. What if we have given an information, then pet will see it and do the corresponding that communication between the environment and agent, which is indicated as, it is called as observation. So how will do the training procedure? Training procedure will normally can do using a positive reward concept. If the dog has fetched the actual stick, then we can provide a reward to the agent, so that always we can update the policy. The policy means it's a correlation. I can say that it's a correlation which connecting between the observation and action. It's a algorithm. I can basically, if you're coming to the reinforcement learning, it is an algorithm, or which can correlate the observation and action. So the dog can possible to change its policy so that it can maximize the reward, right? Through this process, we can do the training process, and which all through the training process, it will they will try to maximize the reward. Finally, this will become trained. Once training is over, then the environment is not required. We can just give the input, so that it will give a specific output according to the policy which is provided, which is saved inside the agent. This is called reinforcement learning. And this learning technique can also apply in T-Rex game. When it's come to the unsupervised learning, skipping some area, there are different unsupervised learning technique is there. Clustering technique, k-means algorithm. Let we are coming to the different machine learning toolbox. Okay, so what do you mean by tool? When it's coming to the machine learning, we have to find out a particular tool. Tool is a software program which can perform the machine learning application very faster and easier concept. So if you have a specific tool is available to you, then it is not required to study it's not required to study an algorithm from the scratch. We can simply apply this toolbox or tool to find out to do a specific purpose. Right. So it is not need to researching and implementing an algorithm. Other than you can simply apply an algorithm which is already implemented in the toolbox for a specific application. Right. And also it will provide a lower barrier for beginners to get a good result. Now, when it's coming to the tool, there are two idea is present. One idea is called a platform, and another classification is called a library. What is platform? Platform is basically it provide all the thing you need to run the project. Right. And when it's coming, library means it provide a specific application. It's provide a discrete capability or part what you have to need to do a project. For example, I can tell you Python is one of the platform which can do our machine learning. I can say that Colab is one of the platform. MATLAB is one of the platform which can do the process and machine learning. And library, I can say that graphical interface is one of the library, and then Scikit is another library which can perform a specific action. Let me come to these are some important tools which is I can say that software tools which is available to do a specific machine learning purpose. So let me, what is the first one is a scikit-learn. Scikit-learn is a it's an algorithm. I can say that it's machine learning platform which is mainly developed in the Python environment, which normally used for data mining, data analysis, model algorithm, classification, regression, and lot of area this is using, and it is open source software. When it's coming to the PyTorch, PyTorch is basically Torch, is an open source machine learning library, and especially useful for building the neural network. And the programming language is a Python, and it can the important advantage of PyTorch is that it can provide variety of optimization algorithm to train a network. Maybe if a neural network, there are a lot of optimization algorithm is available in the PyTorch to train a network. And also we can use a cloud-based platform to do the process, and it's open source software. When it comes to the TensorFlow is basically it is developed in the form of a JavaScript programming, and the language also it is Python. And even the and lot of capacity, but you can say that TensorFlow is difficult to learn for a beginner. When coming to the Weka is a Java-based software tool which can be especially used for the data mining, like or the data pre-processing, classification, visualization. Lot of area Weka are used for this one, and it can easily understand for a beginners. As for it is good for a student as well, and it can easily understand the algorithm, and the online courses are also available related to the code. But thing is that when it's coming to the implementation point of view, even though online courses are available, if we enter into the more detail, the less documentation and the online support also become less when come to the Weka. Now, the Collab is one of the important platform. So provided by Google, it is a I can say cloud-based platform which can do our initial machine learning research very easily. And there are a lot of library which is available. We can say I told you the PyTorch, Keras, TensorFlow, OpenCV. These are the important library which is available in the Collab, and you can apply for this idea for education purpose or do a research also. And issue is that this is associated with the Google Drive. We have to open the Google Drive and you can save the corresponding program in the Google Drive. It is free of cost. When coming to the MATLAB, in MATLAB, basically, there are two different toolboxes available to perform a machine learning task. First toolbox is statistics and machine learning toolbox, and second one is deep learning toolbox. So deep learning toolbox, especially, it is, I think it was available from 2018 onwards, and it can design or train the network, analyze or visualize the data. And you can say that a lot of there are a lot of recent deep learning technique like convolutional neural network, LSTM, generative adversarial neural network. Lot of these deep learning techniques are available in the MATLAB. And also it can support with TensorFlow and PyTorch, exchange mode, through exchange mode. And another advantage is that it can support deep learning process, and like Google Net, NASA Net, RSNet. Also, you can be support using the MATLAB. And problem is that it is a paid software, so it requires a lot of money to purchase a MATLAB thing. There are a lot of other toolboxes also available like Kname and Apache and maybe Shogun, Keras, or Rapid Miner. There are a lot of different toolboxes also. Tools and techniques are available, and I can say these are the 6 important tools which, or a software tool which can be applied for a specific application. When it's coming to the data set, if somebody want to apply a neural network idea, you have to search the data set. These are the some commonly used repository where the lot of data sets are available. And one of the best data set, you can see that UCA repository. You see in UCA repository, this is a structure, and here there is a search window. You can search the corresponding data that you want, and accordingly you can select the data as a classification or regression like that. So most of the data set which is available in the UCA repository. When it's coming to the image data, these are the some image data are available in this Kaggle. Kaggle is one of the lot of image resources are available in the Kaggle and ImageNet. And also you can say that there is a Google data search engine is there, where you can search the corresponding data set by giving their name. And these are some resources if you want to start the machine learning research, if you want to get some good papers or good what is it, journals. These are the one of the best journals available in the online platform, and you can go the corresponding journal and you can search the recent work associated with the machine learning. And these are the conferences which is happening every year, important conferences. And let's coming to the research point of view. There are a lot of research idea we can apply in the field of a machine learning. For example, you can think about more clustering, or we can think about a more idea about feature selection, feature creation, or maybe lot of or maybe algorithm development like deep learning development or adaptive system, or maybe you can think about a new deep learning or deep learning algorithm or other training algorithm which can train the network. There are different research point of view which is available. Thank you very much. So if you have any question, you can ask.
Thank you, sir, for this wonderful session. Those who are into the area of this research on machine learning, definitely they will benefited, because you have covered the concept, basic concepts, and how that is they can utilize the idea. Clearly, you have covered. Thank you so much, sir.
Okay, basically I have focused this for the UG students and PG students, those who want to
Yes,
plan
yes.
certain what is research, or those who want to start idea of a machine learning, those who want to study the fundamental concept of machine learning, it may be helpful for you.
Definitely, sir. This is an instruction to the participants. Here we have given in the chat box a feedback link has given. Please fill up the feedback form to get your certificate. And dear participants, if you are having any queries, please respond. Sir, here Mohandas sir has given a comment. Most of the ANN and fuzzy systems deal with numeric data, but in reality, the real data may be of a wide variety.
Actually, I can not audible. Your sound is breaking.
Is
I'll
it?
see you the chat box.
Yeah, it is there, sir. Please.
Where is the chat box? I cannot possible to see it.
Am I audible now? Sir, it is there in
Hello,
the...
your sound is breaking actually.
Mohandas sir, can you respond?
Hello?
Hello?
Yeah, now I can audible.
Okay. Shall I read it, sir?
Yeah.
Most of the ANN and fuzzy systems
Still sound is
deal
again
with...
breaking. Sorry. Still I
Is
can't hear.
it? Sir, you please go through the chat
It's
box.
better one
It
thing.
is there.
If you have any,
Right.
you can make a draft format and mail me so that I can send the.
Sabit sir, can you help?
Yeah. Wait 1 minute. Sir, shall I read it out?
Yeah. Now I can audible.
Mohandas sir has asked, most of the ANN and fuzzy system deals with the numeric data, but in reality, the real data may be of wide variety. An algorithm that can deal with the variety of data will be a formidable one. Your comment on this?
Yeah, that is correct. Basically, the thing is that there are variety of data are available. If you are applying a neural network and or maybe a fuzzy logic system, the selection of data is a very important strategy. And when we are coming to a data selection, if our variety of maybe if you are going to train a network using a specific data, if either the data should containing all the information associated with the network or associated with the model, then only we will get a better response according to this one. And also the variety of learning algorithm is also available. But what I understand that as per the training, there is no I can say correlation between a training algorithm and data set. If you want to select a particular training algorithm for a specific data, only option which is available, we can say the trial and error. So through a trial and error and accuracy measure, we can choose a particular algorithm which is associated with a fixed data.
So participants, any more questions? One is there, would you share the recording of the presentation? Yeah, of course, it will be there in the IEEE Malabar Subsection YouTube channel. If you can go there, it will be available after 2-3 days. So you can get it from there. Harish V has asked for recordings of this presentation. Sure, we'll be sharing in the IEEE Malabar Subsection YouTube channel. So you can get it from there. So Mohandas sir is raising.
Sir, you can comment based on.
Can you hear me?
Sir.
Can you hear me? Hello?
Yes, sir.
Yeah, yes, sir.
See, basically the major problem with the neural network and fuzzy logic was the problem of selecting the right kind of learning mechanism. Because as you said rightly, the learning depends upon the how successful the system is going to be, or the algorithm is going to be successful. To a certain extent, it depends on the type of data also. The major problem in most of the intelligence systems, the so-called ANN, whatever it is, to choose the right type of data that is required for learning, and the choice of the algorithm. So most of the failures in ANN and fuzzy logic was because of the methodology, a systematic methodology to choose the algorithm, and also the configuration of the algorithm, or maybe the number of hidden layers, or number of input node, number of output nodes, and all those things. So that was the problem. That was a challenge. So like that, when I'm talking about the large variety of data, I don't know, because probably I may be a little obsolete, but it becomes a very complex thing. And moreover, data convergence, learning how far it takes time to learn. A neural network was learn. For example, if you use backward propagation, it was taking a phenomenally long time. So such problems has it been solved already in your new methods of machine learning algorithms and all? That's my question.
Exactly, sir. Sir, actually, your sound is breaking. I couldn't get what you are informed. Anyway, what I can understand, basically, there are lot of correlation. We have the selection. I can say the selection of a best training algorithm and the selection of a network is an important concept when you are coming to the machine learning. Even in the case of a neural network also. So that can be considered as one of the I think till now nobody has. There are a lot of techniques, research point of view, there are a lot of techniques are available, even though till nobody has found out a specific correlation between the algorithm and network which has to be provide a better result, which will give you a better accuracy, like that. So still it can be think about as an open problem.
Okay, thank you. Thank you.
Okay, I think no more questions are there in the chat box. We will wind up. So once again, on behalf of IEEE Malabar Subsection and IEEE Malabar Hub, we express our sincere gratitude to our speaker, Dr. Shihabudheen KV from NIT Calicut. So thank you, sir, for giving for spending 1 hour with us and delivering a wonderful section on machine learning. It was a fine, like basic, like you said, that it will be good for our PG and UG students. Thank you, sir. Thank you. Hello. Hello.